Have you ever wondered how the idea of a reusable spacecraft came about? The genesis of this revolutionary concept traces back to the late 1960s. NASA, the United States' premier space agency, was in a period of reflection. The Apollo program had been a resounding success, but the cost of building expendable launch vehicles like the mighty Saturn V was astronomical. Each majestic rocket was a one-shot deal, its components discarded in the ocean after a single use. NASA yearned for a more economical approach to space exploration, and so the seeds of the Space Shuttle program were sown. The goal was audacious: to create a fleet of reusable spacecraft capable of conducting a wide array of missions. This was not just about deploying satellites or conducting scientific research, but also about assembling and servicing space stations. By the early 1970s, NASA had officially initiated the Space Shuttle program. The plan was to develop a reusable spacecraft system, a winged orbiter that could glide back to Earth, solid rocket boosters to be jettisoned and retrieved, and an external fuel tank. It was a complex and ambitious project, and the road to realization was riddled with technical and engineering challenges. Yet, NASA's determination was unwavering. After years of rigorous development and testing, in 1977, the first prototype orbiter, known as Enterprise, emerged. This vehicle was put through a series of atmospheric test flights to validate its design and capabilities, marking a significant milestone in the program's journey. The Space Shuttle was more than just an idea now. It was a tangible, flying machine. This reusable spacecraft was poised to revolutionize space travel, promising to provide frequent, cost-effective access to the final frontier. The Space Shuttle program was a promising solution to the high costs and one-time use nature of traditional launch vehicles. It represented a bold step towards a future where space was not just a destination, but a place where humans could routinely work and explore. Indeed, the inception of the Space Shuttle program marked the dawn of a thrilling new chapter in the annals of space exploration. The journey from concept to reality was not without its hurdles. Indeed, the path to developing the first reusable spacecraft was filled with challenges and significant milestones that had to be overcome. As NASA embarked on the ambitious Space Shuttle program in the early 1970s, the primary goal was to create a reusable spacecraft system. This included a winged orbiter, solid rocket boosters, and an external fuel tank. The idea was revolutionary, promising to change the paradigm of space travel and making it more cost-effective and frequent. But it was easier said than done. The program faced a myriad of technical and engineering challenges, from grappling with the complex aerodynamics of a reusable orbiter to devising robust heat shields that could withstand the intense heat of re-entry. The challenges were daunting, yet NASA's engineers and scientists were undeterred, tirelessly working to transform the concept into reality. After years of rigorous development and testing, the first prototype orbiter, Enterprise, was unveiled in 1977. Named after the fictional starship in the popular television series Star Trek, Enterprise was a beacon of hope, a tangible symbol of the future of space travel. But before it could embark on any space mission, it had to prove its worth here on Earth. Enterprise underwent a series of atmospheric test flights known as approach and landing tests to validate its design and capabilities. These tests were critical in assessing the orbiter's performance during the most dangerous phases of a space mission: ascent, orbit, and particularly re-entry and landing. The tests ranged from simple taxi tests on the runway to free flight tests where the orbiter was dropped from a Boeing 747 aircraft to glide and land on its own. The tests were successful, demonstrating that the orbiter could indeed fly and land like an aircraft, validating the concept of a reusable spacecraft. These tests were not just a technical success, but a morale booster, instilling confidence in the team that had worked tirelessly to bring the idea to fruition. With the successful test flights, the stage was set for the first operational mission. The Space Shuttle program was ready to transition from theory to practice, from concept to reality. It was ready to make history. April 12, 1981, marked a new era in space exploration. With the launch of the first operational mission, STS-1, the Space Shuttle program moved from conception and testing into its operational phase. This mission, piloted by astronauts John Young and Robert Crippen, saw the orbiter Columbia lift off from the Kennedy Space Center in Florida. This was a momentous step. It was the first time a spacecraft designed for reuse had been launched, signaling a new chapter in our relationship with the cosmos. As the years rolled on, the Space Shuttle fleet expanded to include 5 magnificent orbiters: Columbia, Challenger, Discovery, Atlantis, and Endeavour. Each spacecraft was engineered for multiple missions, creating a fleet of reusable vessels that could be sent on a variety of tasks. This was the realization of a dream that had begun decades earlier, with the desire to create cost-effective, frequent access to space. The operational phase of the Space Shuttle program was characterized by numerous achievements. The fleet of orbiters undertook a staggering variety of missions. They deployed satellites, conducted scientific research, and even rendezvoused with and serviced space stations. The program made an indelible mark on space exploration and scientific understanding. One of the shuttle program's most notable achievements was the deployment of the Hubble Space Telescope. This instrument has revolutionized our understanding of the universe, providing breathtaking images and invaluable scientific data. Another significant achievement was the construction and maintenance of the International Space Station. The Space Shuttle was instrumental in assembling this outpost in space, ferrying both crew and materials to and from the station over multiple missions. The operational phase of the Space Shuttle program was a time of unprecedented achievement. It was a period in which humanity's reach extended further into space than ever before. It was an era in which our understanding of the universe expanded dramatically. The Space Shuttle program was making strides in space exploration, but it wasn't all smooth sailing. The program faced numerous challenges, some of which led to heartbreaking tragedy. Yet, through it all, the spirit of exploration and discovery remained undimmed, propelling the program forward through both triumphs and trials. Space exploration, as groundbreaking as it is not without its risks. The Space Shuttle program, despite its remarkable accomplishments, was marred by tragic events that shook the world. In the frosty morning of January 28, 1986, the Challenger orbiter disintegrated just 73 seconds after liftoff. This catastrophe claimed the lives of all 7 crew members on board, including Krista McAuliffe, a schoolteacher who was set to be the first civilian in space. This was a disaster that not only rocked NASA but also the entire world, leaving a profound impact on the future of space exploration. Fast forward to February 1st, 2003, another tragedy befell the program. The Columbia orbiter, while re-entering Earth's atmosphere, disintegrated, taking with it another crew of 7 astronauts. These incidents underscored the inherent risks and dangers of venturing into the great unknown. They served as stark reminders of the human cost that can come with pushing the boundaries of our world. In the aftermath of these disasters, NASA underwent significant changes. Safety protocols were revised and reinforced, and a renewed emphasis was placed on the well-being of astronauts. The tragedies also spurred on a wave of technological advancements aimed at preventing such incidents from happening again. Despite these tragedies, the Space Shuttle program continued to forge ahead, pushing the boundaries of human achievement. These painful lessons have not deterred us from reaching for the stars, but rather, they have made us more determined to explore the cosmos responsibly and safely. The final mission of the Space Shuttle program marked the end of an era. With the launch of STS-135 in July of 2011, the iconic Space Shuttle fleet took its last voyage into the cosmos. The orbiter Atlantis, carrying a crew of 4 astronauts, embarked on a 13-day mission to resupply the International Space Station, a fitting swan song for a program that had played a pivotal role in the station's construction and maintenance. As Atlantis touched down at Kennedy Space Center on July 21st, the curtain fell on the Space Shuttle program. 30 years of innovation, exploration, and discovery came to a close, leaving an indelible mark on the history of space exploration. But the retirement of the Space Shuttle fleet was not an end, but rather a new beginning. NASA, always looking towards the horizon, shifted its focus to new exploration initiatives. The development of the Space Launch System and the Orion spacecraft signaled a bold new direction for human spaceflight, one aimed at returning astronauts to the Moon and eventually reaching the red sands of Mars. The Space Shuttle program, despite its challenges, leaves behind a legacy of technological advancement and human achievement that continues to inspire the future of space exploration. It stands as a testament to human ingenuity, a reminder of how far we've come, and a beacon guiding us towards the next frontier.